In this video, my goal is to run 24 miles and do 24 derivatives in 24 hours. There's a chance this video doesn't see the light of day. If I pull a muscle or if I just can't complete 24 miles within this 24 hours, then the challenge will be failed and I just probably won't post it, but I'm gonna try my best. I'm a little bit nervous, but I'm also very, very excited about doing this challenge. I'm gonna show you all my miles. I'm gonna show you how fast I run each mile, and I'm obviously going to show you all 24 derivatives that I do. Now I'm going to break this up into a few different sections. There's going to be some sections where I'm just running, and like I said, I'll show you the mile, the path that I took, and how fast I ran it in. My goal for each mile is going to be to run each mile in under 8 minutes, and if I can do that, under 9 minutes. But my goal to start is going to be 8 minutes, so we'll see how it goes. And I don't really have a goal for the derivatives. I'm just going to do them for fun. They shouldn't take too long. I'm not going to make any of them extraordinarily difficult, but I did want to do them because this is a math channel and I enjoy doing math. So let's jump into the first couple miles and see what we can do. So I'm just about ready to start the first couple miles of this challenge, and like I said, I'm a bit nervous. Haven't done anything like this in my life before. I run pretty regularly, and I play soccer pretty regularly, so athletically I think I can do it. It's going to be really difficult mentally though. And as you can see, it is currently 12:06 Wednesday, May 22nd. I'll see you guys after my first mile and see how I did. Here we are, guys, 1.5 miles down. Put my time right down below. I'm gonna go in, do a couple derivatives for you all. I can get a shower, get some sleep, and get ready for tomorrow. It's gonna be a long day. 8 minutes is gonna be really tough to keep up this pace because I was just barely under there, but I'll see what we can do. Let's get on to the derivatives. So over here we have our derivative counter. We're gonna check off the boxes as we go through our derivatives. And here we have our first two derivatives. The first one I chose is cosine squared of 3x. The reason I chose this is because there's a couple different ways you can do it. You can use the identity that the derivative of the cosine squared of x is equal to -2 sine of x cosine of x. And then using that along with the chain rule will give you our derivative f prime of x is equal to -6 times sine of 3x times cosine of 3x. So that's an interesting way to do this. Another way you could do this is by breaking this into cosine of 3x times cosine of 3x and using the product rule. That'll give you the same answer here. And then lastly, you could do a substitution where you set cosine squared equal to u and do a chain rule that way as well, where you have the outer function being this x squared and the inner function being 3x. So 3 really cool ways to do this derivative. This is our first answer of our first derivative here. And for the second one, I just wanted to include a trig function and something that would make us use either the product or the division rule for derivatives. Again, there's a couple different ways we can do this one, but the way I'm going to do it is break this tan x up into sine of x and cosine of x. And now we can use the division rule. Let's see, cosine squared x times x squared. That's on the top from the derivative of the top times the regular bottom. And then we need to subtract the derivative of the bottom times the regular top. So that's going to be negative sine squared of x times x squared plus 2x sine x cosine x. And then this is all over cosine of x times x squared, and that's going to be all squared by the division rule here. So a little bit more of a clunky derivative here. So we can actually simplify this a little bit because we have this cosine squared of x, and this negative sign will combine with this negative sign to give us positive sine squared of x, and this is all times x squared. So we can actually factor that out, and with the identity that cosine squared of x plus sine squared of x is equal to 1, we know that we can rewrite this as x squared minus 2x sine of x cosine of x. That's by carrying this minus into this term over here. And then we can divide this whole thing by x squared times cosine of x, and that is all squared on the bottom. So this is our answer to this derivative, and we will go ahead and check these boxes off when we come back to the derivative section of the video. Let's go run our next miles. All right, I'm up and ready for miles number 2 and 3. Didn't get a whole lot of sleep last night. I was a little nervous. Let's get it. Mile 3 done. Put my time right here. Gonna get some breakfast, get some rest. Might do some derivatives. Might just rest and store up some energy for the start of miles 4 and 5. Run number 3 done. That one was a little bit faster. Probably should pace myself a little bit better for the next one. But yeah, run number 3 done. Let's go do some derivatives. All right, so we have our next 3 derivatives here. The first one, we have a function of z, where 6 over the square root of z cubed plus 1 over 8 times z to the 4th minus 1 over 3 times z to the 10th, and we're asked to find the first derivative. So this is pretty easy. This is just 3 straight power rule functions. But I'm going to readjust them so that variable is in the numerator instead of the denominator. So let's go ahead and do that first. That gives us 6 times z to the negative 3 halves. That's from this 3 inside, the square root giving a divided by 2 in the exponent, and then a negative sign because that z variable is in the bottom. And we can do the same for the other two. So we have plus 1 over 8 times z to the negative 4 minus 1 over 3 times z to the negative 10. Then from the power rule, we can find pretty easily that the derivative of r with respect to z is equal to, let's see, 6 times negative 3 over 2, that'll be negative 9, times z to negative 5 over 2, and then plus 1 over 8 times negative 4, so that'll be negative 1/2, times z to the negative 5, and then minus 1/3 times negative 10, that's going to be plus 10/3 times z to the negative 11. So that's our first derivative there. That'll be our third answer. Now for our fourth answer, I chose an implicit differentiation problem. So we need to take the derivative implicitly with respect to x. So that gives us 6y squared times dy dx, or I'll just call that y prime, plus 8x, because we're taking the derivative with respect to x, so that just stays as its normal derivative, the power rule, which gives us 8x, minus 1 times y prime, or dy dx. And then on the other side, we get 6x to the 5th from the power rule again. Okay, but now we want to separate out this y prime. So we have 6y squared, y prime minus y prime is equal to 6x to the 5th minus 8x. That's just by moving this 8x over here. And again, we want to get everything with a y prime term on one side. So I did that right here. And now we can factor it out. So factoring it out and dividing, we get that y prime is equal to, let's see, this side, so that'll be 6x to the 5th minus 8x over this side with the y prime factored out. So that'll be 6y squared minus 1. And that's our derivative there. And if we really wanted to, we could solve this using differential equations, first order separable method, but we're not going to do that in this video. If you want me to do a differential equations version of this video, let me know down in the comments below. Okay, and finally, I wanted to find the second derivative of a function, where the function f of w is 7 sine of w plus cosine of 1 minus 2w. So we just need to find the first derivative and then the second. So f prime of w, or the first derivative with respect to w, is equal to 7 times the derivative of the inside function, so that's just going to be 7 over 3. And then the derivative of the outside function, so that's going to be cosine of w over 3. So that's this bit here. Now we need to find the first derivative of this bit here. So that'll give us minus 2. That's the derivative of the inside function here. But then this minus sign is going to change to a plus because the derivative of cosine is negative sign. So those minus signs will cancel each other out. So we get plus 2 sine of 1 minus 2w. So that's our first derivative here. And to find the second derivative, we just do the same thing. This is going to be negative 7 over 9 sine of w over 3. And here, this is just going to be minus 4 cosine of 1 minus 2w. So that's the answer to our fifth derivative here. I'll go ahead and mark these 3 boxes for when we get back to the derivative board the next time.
Run number 5 complete. Time was about the same, but I definitely felt it in my legs more that one. Also got pretty hungry towards the end of it, so I'm glad that about lunchtime, I'm gonna go in, get a shower, clean up a little bit, change clothes, and get something to eat and be back out. Yeah, I will see you guys probably for another run, but maybe some derivatives, we'll see. Alrighty, I got some lunch, got rested, and I'm ready to hit the second portion, I guess the second leg of this daily race, if you will. So you got 3 more derivatives here. I went with pretty easy chain rule problems because I like the chain rule. I think it's really interesting. I think it's the most interesting of the first semester calculus derivative rules. So for the first one, again, with the chain rule, we want to take the derivative of the inside and then multiply it by the derivative of the outside function with the inside plugged back in. So here, this is our inside function. The derivative of this function is 6x squared minus 9. That's by moving this 3 exponent down and moving that 1 exponent down from the x, then subtracting an exponent from each, leaving us with x squared and just 1. And then we want to multiply by the derivative of the outside function. So that's going to be just cosine times the inside plugged back in. So this is our derivative here. We're going to apply the same logic here to this problem for number 7. So again, we want to take the derivative of the inside function. Taking the derivative of 7 will give us 0.
and taking the derivative of x cubed gives us x squared times 3. We have this negative sign out front, so we'll go ahead and write that as negative. And then the derivative of the natural log is 1 over whatever's in the inside here. So we have 1 over 7 minus x cubed. And if we wanted to be really specific about this, we could write this as 3x squared times, or over, x cubed minus 7, and just flip this and get rid of that minus sign out top. And then lastly, we have this other interesting problem with the chain rule again, but it also uses a bit of the product rule because we have this t squared function outside here. So h prime of t is going to be equal to, we'll take the derivative of this function first, so we have 2t times the natural log of t to the 5th plus t squared times the derivative of this function. And for this function, we're going to have to use a chain rule again. So we have t squared times 5t to the 4th. That's the derivative of the inside bit here. And that's going to be over t to the 5th, which actually gives us something really interesting. So we have h prime of t, and we can simplify this. So we have 2t times the natural log of t to the 5th. That doesn't simplify down at all. But this function does. We still have 5 out top. But if you notice, we can combine t squared and t to the 4th to give us t to the 6th. And that's all over t to the 5th. So canceling that down, we just get 5 times t. So this is h prime of t here. Alrighty, we're 8 derivatives in. Let's go run some more. Back in the apartment this time. Here's my time. Could definitely use a little more consistency, I think, to work out the lactic acid in my legs. We'll see how the next couple miles go, and we'll be at the halfway point. Alrighty, we've got our 9th and 10th derivatives here. The first one is a trig function with a little bit of a chain rule and a product rule involved, and an exponential function. So kind of everything thrown in together. And this one is just a long trig chain rule function. First, we want to take the derivative of the inside function using the chain rule. The derivative of this function is just 2x times e to the x plus x squared e to the x. And that's the derivative of the inside function. And now we need to multiply it by the derivative of the outside function with the original inside function plugged in. So the derivative of cosine is just negative sine. So we get negative sine of x squared e to the x. And then if we want to simplify this a little bit further, we can factor out an x times e to the x, and that gives us 2 plus x times negative sine of x squared e to the x. And for our 10th derivative, we have tangent to the 4th of z squared plus 1. So there's a few different ways you can do this, but what I'm going to do is I'm going to imagine this multiplied together 4 times and use a combination of the chain rule and the product rule. So taking the derivative of this tangent, we get 2z times secant squared of the inside function, so that's z squared plus 1. And then we have all of these 3 as well. So we have tangent cubed of z squared plus 1. And that is the first part of our product rule. But then for the second part, we're just going to get the exact same thing, and so on and so forth. So actually what we can do is we can simply multiply this times 4 to get what our final derivative will be. So we have g prime of x is equal to 8z times secant squared of z squared plus 1 times tangent cubed of z squared plus 1. All right, that's our 10th derivative. We'll go ahead and mark those off for the next time we come back to the derivative board. Halfway done. Got 12 miles down. Here's my time from the last 2. Feeling not great, but that's to be expected. These next 4 runs to get to 18 miles is going to be really difficult. So the next 6 miles are going to be very difficult. After that, it's the home stretch, but got to keep pushing. Legs are getting tired. Joints are getting a little sore, but we keep moving. Alrighty, so we got our next 3 derivatives here. The first one is a simple product rule problem with a little bit of a power rule involved as well. So first we want to take the derivative of the left function and multiply it to the right function. So that'll give us 6x to the 5th times the square root of 5x squared minus x. Then we want to take the derivative of the right-hand side and multiply it to the left-hand side. But the derivative of the right-hand side is actually a chain rule problem. So we want to take the derivative of the inside first. So that'll be 10x minus 1. And then we want to multiply that to the derivative of the outside function, but that's just the square root function. So we're going to have 1/2 times 1 over the square root of whatever's in the inside function before. So that'll be 5x squared minus x.
And then of course we still need to multiply this by the left-hand side, so that'll be x to the 6. And that's the derivative of this function. Okay, let's move on to the next one. This one's another product rule function, and this one's a little bit easier. So first we want to take the derivative of this left-hand side, so we have g prime of x is equal to 12x, that's the derivative of this here, plus 3, that's the derivative of this here. And this is all multiplied times the natural log of x, that's just the regular right-hand side function. And then we want to add to that this right-hand side function's derivative times the original left-hand side. So that'll be 6x squared plus 3x, and then the derivative of the natural log of x, which is just 1 over x. But we can rewrite this and simplify this by multiplying this 1 over x through to both of these terms here. Alrighty, so that's our final derivative there. And lastly, we have this cool chain rule problem with the exponential function and the sine function. And for this, all we need to do is take the derivative of the top function and multiply it to the derivative of the outside function with the top function plugged in. But we know that the derivative of the exponential function is just the exponential function. So really the hard part here is actually finding the derivative of this top function. And for that, we need to use the chain rule. So here we have x cubed plus 2x squared. The derivative of that will be 3x squared plus 4x. And then the derivative of the outside function, which is sine, is cosine. And then we want to plug this back in. So we'll have x cubed plus 2x squared. And then the derivative of e to the x with this function plugged back in, which is just the same function that we have above. So e to the sine of x cubed plus 2x squared. Cool. So there's 3 more derivatives that we can add to our tally here. So here we have 3 more derivatives that we're going to do. The first one is a chain rule with 2 trigonometric functions. The second one has a couple of different exponentials. And the third one is a product rule to trigonometric functions. So let's jump into the first one. First, what we're going to do is we're going to take the derivative of the very inside function, that's x squared. So we're going to have f prime of x is equal to 2x. Then we're going to multiply that by the derivative of the outside function with the inside function plugged back in. But that's going to be negative sine of x squared. And lastly, we want to take the derivative of tangent and plug cosine x squared back in. But the derivative of tangent is just secant squared. So this is our final answer here. And we can simplify this a little bit by just putting this minus sign out front. So we have negative 2x sine of x squared times secant squared of cosine of x squared. Our second one here has an e to the 2x plus e all to the 1/2 power. So we're going to use the chain rule with this one. And what we want to do is take the derivative of the inside function, and the derivative of e to the 2x is 2 times e to the 2x, because the derivative of e to the x is just e to the x. And so by the chain rule, we want to pull that 2 down here. And then the derivative of e is just 0 because e is a constant. So that's our first bit. And now we want to take the derivative of the outside function. So that'll give us 1/2 times all of this. So e to the 2x plus e all to the negative 1/2. But then simplifying this down a little bit, we can see that this 2 and this 1/2 will cancel. And so we get that g prime of x is equal to e to the 2x times this whole thing here. So we have e to the 2x plus e all to the power of negative 1/2. And finally, we have this double trigonometric function here. And this one's pretty easy. We have h prime of x is equal to, well, the derivative of secant x. So we have secant x tangent x times sine of 3x plus the derivative of sine of 3x times secant x. And the derivative of sine of 3x is just cosine of 3x. We have cosine of 3x times secant x. And again, we could factor this if we wanted to, pull out this secant x from both sides, but we're not going to do that here. We'll just leave it as it is. Just got finished with mile 18. Those last 6 miles, the last 4 runs have just been absolutely brutal mentally because I knew I'm not super close to finish, but it's in the sun. My legs are really feeling it now. So at least hopefully for the last 4 runs, the sun should be completely down. So I should be in the shade. That'll make it a little bit easier. There's a nice breeze going. Temperature will go down and it should be slightly easier than it has been. Yeah, still a little bit of ways to go. All right, so here we have our 17th and 18th derivatives. Our first one is sine of x over e to the x plus 5. So that'll be some kind of division rule there. And then here we have 2 times x to the 4th times cotangent of x,
over 3x squared. So probably a division rule for both of these. Let's go ahead and hop into the first one. So using the division rule, we know that f prime of x is equal to, let's see, the derivative of the top function, so that's cosine x, times the bottom function as it is. So that'll be e to the x plus 5. And then we have minus the regular top function, so no derivative there, that's just sine of x, times the derivative of the bottom function, but that's just e to the x because this 5 is a constant, so taking the derivative of a constant is 0. And the derivative of e to the x is just e to the x. And then on the bottom, we have just the whole bottom function squared. So we have e to the x plus 5 all squared. Let's move on to the bottom function here. So we have 2 times x to the 4th times cotangent of x divided by 3x squared. And again, we're going to want to use the division rule. But I'm actually going to change this cotangent x into cosine of x over sine of x. So I'm going to go ahead and rewrite that here. G of x is equal to 2x to the 4th times cosine of x over 3x squared times sine of x. And from here, we can use our division rule again. So we have g prime of x is equal to the derivative of the top function again. So that'll be 8x to the 3rd times cosine of x minus 2x to the 4th times the sine of x. That's all times this bottom bit, so 3x squared times sine of x. And then we need to subtract the same thing from the bottom. So this is actually going to be quite a long numerator. So we're going to have minus the derivative of sine of x is cosine of x. So we have 3x squared times cosine of x plus 6x times sine of x. And that's all going to be times 2x to the 4th cosine of x. And that's just the numerator. So I'm going to put big brackets around this. And then we're going to divide that by this function down here squared. So we'll have 3x squared times sine of x all squared. So that'll be our final answer there. And again, there might be some way to simplify this, but I don't see anything immediately. So we'll just leave it as it is. All right, we got derivatives 19 and 20 here. So we have f of x is equal to cosine of tangent of x. That's just 2 trig functions with the chain rule. And then we have this g of x is equal to 5 to the power of sine x cubed, which is pretty interesting. We haven't had an exponential without e yet, so I thought I would do this one as well. Okay, let's do number 19 first. So f prime of x is going to be equal to the derivative of the inside function. That's going to be secant squared x times the derivative of the outside function with the inside plugged back in. So that's going to be negative sine of tangent of x. And again, we can simplify this down just by moving this negative sign out to the front. And then our second derivative here, we have g of x is equal to 5 to the power of sine x cubed. So again, we're going to use the chain rule. And we want to take the derivative of this in the exponent first. So the derivative of sine x cubed we'll also need the chain rule for. So we have g prime of x is equal to the derivative of the very inside, so that's 3x squared, times the derivative of the outside, which is cosine, and then x cubed plug back in. And then now we need to take the derivative of this function and plug sine x cubed back in. But the derivative of a exponential like this is just the natural log of that number. So the natural log of 5 in this case, times 5 to the sine x cubed. And if you notice, we actually do this every time we take the derivative of e to the x, but this natural log of e is just 1. So we just kind of leave it off the end, if you will. Okay, so there's 2 more derivatives. We got 4 more to go. Alrighty, here we have derivatives number 21 and 22. For the first function, we just have a couple power functions multiplied together. And then for the second function, we have this iterated exponential where we have 2 to the e to the 4x. So we're going to have f prime of x is equal to 6x, that's the derivative of the left-hand side, times 4x cubed plus 1, plus the derivative of the right-hand side, which is 12x squared, times 3x squared minus 2. And there's actually a little bit of simplification that I will do this time. So we have 6x times 4x cubed. That'll give us 24x to the 4th, plus 6x. And then here we have 12 times 3, both times x squared. So that gives us 36x to the 4th. And then minus 24x squared. That's from this minus 2 times this 12x squared here. But we can combine this 24 and this 36 times x to the 4th. So that gives us, let's see, 60
times x to the fourth minus 24x squared plus 6x. Now for our 22nd derivative. This one, we just need to apply the chain rule over and over again. So first, we want to take the derivative of the inside function, so that'll just be 4. Then we're going to multiply 4 by the derivative of the top part of this exponential, so e to the 4x, but that's just going to be e to the 4x. And then we want to multiply this by the derivative of this outer function with the inside function plugged in. So that's going to be the natural log of 2 times 2 to the e to the 4x. And this is our derivative for g with respect to x.
Unfortunately, at this point, my footage corrupted after I ran my 21st mile, and my legs were absolutely dead at this point. I could not drag myself to run miles any faster than I was. Here are my times. I was still running relatively quickly, but my body was absolutely failing very, very quickly. Here are the derivatives, and then I'll show you my reaction at the end.
Here we have our 23rd and 24th derivatives. So this first one has e to the e to the e to the x. And this one here has sine of cosine of sine of cosine of x. Just a couple stacked functions that I thought would be pretty fun. So for this first one, what we want to do is take the derivative of the top inside function, so that'll be e to the x, and then multiply it by the derivative of this function with this function plugged in, but that's just e to the x. And then we want to take the derivative of this function and put that inside as well. So we have e to the e to the e to the x. And lastly, our last derivative of the day, we have the same kind of thing. So we want to take the derivative of the inside function. That's going to be minus sine of x. That's the derivative of cosine. And then we multiply this by the derivative of sine with cosine of x plugged in, but that's just going to be cosine of cosine of x. Then we want to take the derivative of cosine and plug this whole bit in. So we have times negative sine of cosine of x. And finally, we have times the derivative of this with this whole thing plugged in. So we're going to have cosine of sine of cosine of x. And you can notice that we can remove this minus sign here and this minus sign here. Those will cancel out. And so we're left with sine of x times cosine of x times sine of cosine of x times cosine of sine of cosine of x. All right, we're done with our derivatives. Let's go finish the video by completing our last 3 miles.
Just got done with the 24th mile, and wow, that was definitely the hardest thing I've ever done in my life. My body is like aching from, maybe not head to toe, but pretty close to it. Just absolutely physically the most difficult thing I've ever done. The reason I'm putting it on this channel is because I like to challenge myself mentally, and I think that's why a lot of you are subscribed to me. We challenge ourselves with different math puzzles and stuff and other different puzzles. The reason you're at the channel is because you like to challenge yourself mentally. And this is another way of doing that. I challenge myself mentally solving puzzles and solving derivatives, sure, but I also challenge myself mentally to try to push myself to accomplish a goal that seemed very, very far-fetched. That's why I'm putting it on this channel. I hope you guys really enjoyed it. It's time for me to go take some painkillers and go to sleep, get some food in some kind of order. Thanks for watching. I think that's more than enough for now.